Hey guys, your boy Chilla here. Welcome back to Chill. Continuing on with our creation of our CLI framework. Today we're gonna do a little fun, creative C++ programming to kind of finagle a very nice syntax for our framework here. But before we get started, just gotta go over a couple things. First, in the last video, this code that I created has a little bit of a flaw in it because, well, this constructor is being called even before we enter main, right? Because we have this global instance. And so what that means is that if we get a failure, we're going to call chillog error before we boot the IOC system. And that is not going to like that. And it brings up a very interesting point. But I mean, we don't really need to come to it right now because our new CLI framework is not going to have this issue. Couple things I did off screen. I cleaned out that test code from main. I added the header source pair for our CLI framework code that we're going to do in this video. And I also moved the settings for VC package. I think we put them in the project, window app project. I moved them out of there and into its own prop sheet file. And this is interesting because these properties, you can't actually edit them in the GUI for your prop sheets. You have to manually edit the text if you want to set VC package settings in the prop sheets. They never added it to the GUI. So, but I do want to do that because I want to add that for all my projects now, not just for window app. So it's better to do it with a prop sheet. All right, now with that housekeeping out of the way, let me show you what we are working towards. Here's our end goal. We want to be able to create a structure. We want to put members into the structure that you can access globally. And when you put a member in the structure, it's automatically going to register it with the CLI 11 app. This structure will automatically have all the mechanisms in it for managing a singleton instance and parsing that instance with an init function. So all the boilerplate is going to be pulled out into this layer here in the framework. And when the user developer just wants to define their options, they just got to inherit from the container type and then fill it with these option types, either a flag option or a parameterized option. So we can see right here, we've got three classes that we need to define. We need to define an options container class, and we need to define classes for the options elements, flag elements, and your parameterized option. Now, naturally, the option container is going to hold the CLI 11 app object that you register all the options to. So let's start by creating this one first. Now we're going to split the definition of the container into two parts. And one part is going to be just a normal class. The other one's going to be a templated class. And it'll be easier for me to explain why we do this after we've actually done it, because then I'll have something to show you. So there's the non-templated one. We call it options container base. Its only reason to exist is to be inherited by the templated one. For the most part. So we're going to put an underscore after it because the end user is probably never going to have to interact with this one directly. And it's got one function, init, and it has an app, and it has a little boolean to check whether the system has been finalized or not, whether it's ready for you to start, reading options. Because we are returning an optional, we should probably include that. And let's look at the implementation of this function. It's not that complicated. You call app.parse with your argc, your argv, and then you set finalized as true, and you return an empty optional. But if something went wrong, we're going to call app.exit, give it the parse error, and that will allow exit to print out, the error code. And then we return what app.exit gives us, which is the exit code that you should use when returning from your program. Now, the second part of defining the container is going to be templated. So let's do template class T, options container, and now we're going to inherit from the base. So this is going to contain all the parts that are dependent on this template parameter. And so you might be wondering, why do we need this? Well, the end user is going to define their own static structure, and we need to know that static structure because we want to manage the singleton instance of that structure in here. We don't want the end user to have to reproduce the boilerplate of creating a singleton and accessing it. We want to pull that all out into a layer that is reusable. And by using the CRTP pattern, the curiously recurring template pattern, I think that's what it is, we can do that. So This class actually contains no member data of its own. It's basically all just static stuff. We define a get function to get our singleton. So we have a local static here that is going to be dynamically initialized the first time someone calls this get function. And then we just return opts. Let's include core source. Where is it? Probably in utilities, assert. So we got our assertion here. Now we're going to put a public static getter. The public one is going to call the private one, but it's going to do something extra. So what this is doing is now if someone external to our system is trying to get the instance, we are going to throw an assert if it hasn't been initialized yet. So trying to get it before it's initialized, that's not good. Can also give people a way to check whether it's been initialized yet. And let's make a public init function, which is just going to get the instance and then call init on that. This is not right. This is for the future. This is not yet something that we need to worry about. So let's get that out of there. So here's a static interface for the options container. You can initialize, you can check if it's initialized, and you can get the initialized instance to start working with it in your program. All right, so that is this part of the framework done. Now we need to handle the elements of your options struct. So let us start. Well, first of all, they have commonality between them because they're both going to be tied to an option object. So let us define a base class that basically, holds all the commonalities between these. So options element base is going to hold a pointer to the option. It's not an owning pointer because the actual option object itself is owned by the app. So this is just a pointer to an option that is, being managed by the app. And we got a few functions that all elements will have. We got the Boolean, which can check if the option has been supplied on the command line, and opposite of that, which is the not. And you can get the name of the option. And those are implemented thusly. Option object itself, if you cast it to bool, it does the same thing here. So we're basically just forwarding that call. And not is just the inverse of that. And get name just calls p-option get name. Important to note here that we made p-option here protected so that the derived classes will be able to access it because they will need that. All right, let's create one of those derived classes right now. We'll start by creating the parameterized option that takes, another option argument that follows it. And arguments can have different types. They can be integer, they can be string. We will enable that by templating this class. So you decide the type of it by providing a template argument. So we need a variable to store that t data. And let's call it t data. There you go. Now the most important part of this class is the constructor because this is how it is going to register itself to the container. And here is the secret sauce. It takes in a pointer to its container, which we'll just call p-parent, I guess. Now, here is one of the main reasons why we split this up into a templated part and a non-templated part. It's because now we can have a pointer to the non-templated part, and we don't need this t, which is only defined later by the user of this class. So having the ability to have this pointer to this non-templated class it enables a lot of important stuff for us. So that's one of the main reasons why we split it up like that. And we will take in the names of the thing and the description. And then in here, it's very simple. We do p option is equal to, and I don't think I told you about this in the previous video, but when you do app.add option, it returns you a pointer to the option that you can use to now further customize that option. So that's important. So we want to store that. Now here's a problem. This is, it's protected, but it's not accessible by options element base. So we need to make it accessible. So we're going to add a function to options element base, protected function, that is to get the app given a pointer to the base. So this is a little key that anyone who inherits from options element base can use to access this private data from the container. So now we can just call get app p-parent dot add option. Then we move in the names, we move in the description, and we bind the data reference in here so that it's connected. And there you go, that's it. We have registered our option. We probably have to implement this. So it's implemented like this, returns app, but there is a problem, and that is that app is private, so even this class can't access it. We've got to give access to the one base class there. So we do friend options element base. And doing things like this, making this get app accessor key function in the base, and then making options element base a friend. Now you don't have to make a friend for every single type of options element. You just make the base the friend, and then everyone who inherits from base gets access to this key function. All right, and this should be enough for us to get a little test going to see if we're on the right track. All right, we got a little problem here, and I think I know what it is, just because options element base hasn't been defined yet. So we can just do class, do a little forward declaration there, inline, and that has succeeded. So now let's see what it takes to actually use this thing. So we're gonna go here, we're gonna add a new item. I'll call that CLI options.h. We'll include the CLI framework here. We'll create a namespace for our thing. And inside that namespace, we are free to do a using namespace to import chill CLI in here. And then you just define your custom struct of options that you are going to support in your program. So we'll call it options. You could call it whatever you want. And the important thing is that we inherit from the options container templated on the options type that we are defining. This is the CRTP. And then we can add an option. And let's add an int, and we will call it num windows, because that's a useful option for us in our program. This, you always have to pass in pointer to the thing that you're creating. Num windows is the name of the option. Number of windows to spawn. There you go. Now for a little quality of life here, we're going to do using. Make a shortcut. Opt in the global namespace is equal to CLI options. So we make a shortcut to accessing this structure. Then in main here, let's include CLI options. So here's how you should initialize your options. We do if auto code is equal to opt init. You call the init function when you are ready to parse the command line. You get an optional code back. If it's empty, that's fine. Everything went according to plan. If it's not empty, let's do chillog.error. We'll say failed to parse options, and then we'll return the error code that it told us to return. But if it's all done, then let's make a little shortcut here. I often do this, a reference, and that's just opt get. You can type opt get every time, or you can just make this little shortcut here. I like the shortcut. And now for our window pointers, we'll go opts dot num windows ternary. And if it's true, then we use opt dot num windows dereferenced, get the value. And if it's false, then we're going to use the default number of windows, which we'll say is 2. Now there's a problem here. I didn't actually define this. I kind of skipped a step. Yeah. So we got this data in here, and we're binding it to the option. Very nice. We have no way of accessing it. It's private data. So how do we access? Well, we're going to use the same paradigm that's used by like std optional, which is we're going to do constant t reference operator star const. So you just do put a star in front, and that gets you the actual value stored inside of this option argument. And return data underscore. There you go. Now that should make, let me see here, that should make this bad boy happy. Now we can check to see whether it's present. If it's present, use the value. If not, just go with some default. So now if I run it with the option not specified, I should get 2 windows, and I do get 2 windows. But if I check this box, I should get 5 windows, and I get my 5 windows. Beautiful. That is working as intended. That's a commit in my books. One small little improvement we can make here before moving on is we can implement all the different special members. Well, not implement, delete them, because it doesn't make sense to copy an option or to move an option. So we'll just delete all of these. It's always good practice. Now, the other kind of element that you can put in an option container is a flag. So let us make a flag. Now flag doesn't have an embedded type T, so it doesn't need to be templated. That makes things easier. So the data is just going to be fixed as a bool. And because it's not a template, we can move the implementation of its member function into the CPP file, which is always better for compile time's sake. And that implementation is dirt simple. We use our little key function to get in the back door, and we call, instead of calling add option, we call add flag, and we move in the names, the boolean to bind, and the description. Basically the same thing as we had before. So let's add a little flag option here. Seems useful, this one. And there you go. Now you can add flags to your container of options in a very convenient way in here. We should probably do something to check for that. So we just go like, if shit the bed. Is that how you spell thoroughly? I don't have any confidence. Let's return a nice error code there. Beautiful, beautiful. And now if we were to run this, we run it without the option, we get it like this. Seems fine. We run it with the option, and we get our error. Beautiful. Consider the bed thoroughly shat upon at WinMain. No lie detected. Okay. All right, now the final issue that we have to address here before we finish the video is, well, let me show you. So CLI 11 automatically generates help for you, and the option that is available for is help. If I run it with this option, the program does not run. We get an error, failed to parse options. And then the program exits with code 0. So init returned a non-empty optional with a 0 in it, which is not an error, but it's saying we got an error. And also we did help. Where is that help text? Well, by default, CLI 11 puts that out into std out. That is not useful for our WinMain program. That goes into the void. We are screaming into the void. Luckily, there is a solution. We can do this in a very sexy manner. So, although by default it goes out into std out, we can make it go somewhere else. We can give it a stream to go to. So let us include string stream, and we are going to add in here, we're going to add an output string stream, call it Diagnostics. Now when we init, here's the thing that I told you we needed later. Put a little bool in here, capture Diagnostics. We'll change this one to match. So now what we're going to do is, if we have been requested to capture Diagnostics, we're going to change the way we call app.exit. We are going to pass it our stream that we have here and capture everything from std out and std error. So when you have an error, like you put a wrong value as an option, that'll go to std error, and if you just print help, that would go to std out. And we want to capture both, put them in the same thing. We'll put them in the same bin for now. We could separate it later if we need to, but I don't think we need to. Now we do the same thing for init. You have the option to capture Diagnostics, and we'll turn that on by default, because by default we're probably not going to be using this framework in a console application. So now this has to go into here, and now we have to call init with this bool. Okay, so now we can capture the Diagnostics by default into this string stream. How do we get them? Just put a little static function in here, returns a string, get Diagnostics, and we'll call get Diagnostics string. Beautiful. And now let's do UTL to wide opt get Diagnostics. And let's not add a trace to this because it's not very useful. We always know the path to getting to this point. So we'll make that no trace. And now we should get our help info. So we run this, and here is the help. It says here's our options. Help, of course. Shit the bed, and num windows, which takes an int parameter argument. There you go. Beautiful. And that also works for, we get some other stuff for free. Like for example, if I do num windows and I put a non-integer value in there, it's going to say, hey, could not convert num windows equals pubes. Fair enough. Understood. All right. So that's the minimal implementation, the bare bones of our CLI framework system. And I hope you'll agree, it's a very clean thing to use. Once you've got this framework built, it is very easy to define your options and use them in your program. But you know me, right? I can never be satisfied with just the simple thing. There's so many ways that you can use CLI 11 to customize your options. And I would like to expose that through this system here. So in the next video, we are going to look at a bunch of bells and whistles improvements to this baseline system that we've created. And that may or may not lead us into doing a little bit of light C++ meta programming. There's an oxymoron if I ever heard one. But anyways, until then, thanks for watching. Hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you again with some more chill.